One of the most common questions we get asked at IRIS is, when we're looking at utilizing inspection windows or infrared windows, how do we go around specifying exactly what we need and what should we consider during this process? So this webinar is really to go over how to specify a maintenance inspection window. So when people look at maintenance windows or vision windows or infrared windows, and these are common terms you're gonna see in the field. But why do we need these things? So looking at an infrared window, you need to consider that infrared cameras can only measure the temperature of the objects that they can see, and infrared windows allow infrared cameras to see the components and connections within inside an electrical cabinet with the cupboards and doors in place in what we class as an enclosed and guarded condition, which is the safest condition that we can use when trying to look inside the panels. Now, infrared cameras cannot see through glass or plastics, and this is a common misconception. The visual viewing planes that your eye can see through, an infrared camera can't see through them because they don't enable the infrared radiation to transmit through them. So we need special lenses and materials that enable that infrared radiation to pass through the lens, so we can make a reading using the infrared cameras. Now, infrared window lens materials are typically specialized infrared transmissive polymers or fluoride-based crystalline materials. There's a whole bunch more you can use, salt, diamonds, etc. But the most common materials I use are polymers and fluoride-based crystalline materials. So what we started to think about is, why stop at infrared inspections? An infrared window makes you just think it does infrared inspections, but there are many types of inspections that we have to do other than infrared, and these include but are not limited to the following: airborne ultrasound. So we need to apply access for ultrasound equipment, motor current analysis, partial discharge testing, corona inspections using UV cameras, power quality monitoring, and not last but not least, the visual inspection. So all of these inspections have to be done. So when you're looking at an inspection window, why don't you put something like a maintenance inspection window that allows for all of these technologies to be used from one simple point of access? So there's significant investment required to realize the benefits of an inspection window. If you're going to go to the trouble of putting one of these in, you really want to make sure it works and works for everything. So by limiting the scope of the devices, that we're not really maximizing return on investment, and we may limit its future use. So really think about what you're doing when you're looking at these inspection windows. So what we say is a maintenance inspection window should allow all inspections to be completed by all of the equipment that you intend to use in a closed panel energized inspection of your electrical systems. The maintenance inspection window should allow closed panel inspections of visual, infrared and UV, ultraviolet spectrums, should include ultrasound and partial discharge access points, and should be available not just in round, but round, rectangular or custom built solutions. And custom built solutions are becoming extremely popular. When you look at this video here, what we do with a custom built solution, we take an existing cover and we actually make a maintenance inspection system that just bolts straight on in place of the old cover. Now these then enable me to see a visual, an infrared, a UV, take partial discharge and ultrasound measurements where applicable, and even have inbuilt temperature monitoring as well. So again, it becomes an inspection system, but in some cases it also becomes the access point for the de-energized maintenance as well. So when specifying your Windows system, there are a number of specifications and certifications that a maintenance inspection window should meet. First and foremost, you need to consider the field of view. The field of view is basically what you can see through your inspection window. The window design parameters that you need to require, the viewing lens material requirements, the relevant certification requirements, and the performance specifications of the window itself. What do you want it to do, and the warranties. Now, what is the warranty of the system that you're putting in place? So now I'm going to review each of these in a little bit more detail. So first, let's look at field of view. Now, the field of view calculation is based on the viewing angles of the cameras and the equipment used in the window systems that you have in place. So full consideration must be given to all internal obstacles, such as phase dividers, internal cable routings, as well as the physical designs of the doors and covers. Some have reinforced or internal covers, etc. So when you're looking at field of view, there's going to be some mechanical obstacles, but the calculations are based on the lenses of the systems that you're using to look through the window itself. So as I said, the field of view is limited by the actual camera lens itself. So when we look at that, typical field of view of an infrared camera is 22 degrees in the horizontal and 16 degrees in the vertical. Now these figures are just a guide, and we're using these to, I'm going to go through some basic calculations to work out the size of an inspection window. But the formula that we have here is WS equals TS minus 2 times the tan of the CVA divided by 2 times DCT times 3, which doesn't mean a lot, but basically what it means is WS is window size. The target size is, so basically when I'm looking at the window size, target size minus 2 times the tangent of half the camera viewing angle. So that's a tangent of 11 degrees because we're looking at 22 degrees here. Obviously if you're doing it in the vertical, it will be 16 degrees or 8. DCT is distance from cover to target. Okay, that's basically what you need to know there, and we have a multiplier of 3, and that's the maximum viewing angle multiplier. So what we've worked out is you can increase a fixed viewing angle by a factor of 3 and not exceed the angle of incidence of the target, which gives all sorts of issues to the thermographer. So this is the formula we're going to use, and then we put that into real terms. In the sample calculation, we can look at an enclosure with a distance from the cover to internal components of 8 inches. With an internal target width of 18 inches. So that's my target size I'm looking at. And to calculate the minimum window width required to see all the targets with one single window, we use the formula we listed in the slide before. The calculation is basically 18 minus 0.839, which is half the tangent of 22 degrees, times 8, which is the distance from cover to target, times the multiplier. So that equals 18 minus 9.34, which gives me a maximum window width required of 8.66 inches. Now you can use multiple windows, but the more windows you use, the more money it costs. So using one single large format window to your desired specifications is normally a significant less amount of money significantly less money, better savings on the installation as well. So also we're going to look at the inspection window design requirements. So the inspection window assembly lens materials must comply with the testing standard requirements for flammability, impact and load, comply with the OEM specifications for materials and color, because again the OEMs will have significant specifications. You can specify the type of window you want, but the OEMs are going to have their own requirements that need applying. The inspection window lens cover must be attached to the window and not be removable to prevent the cover from being lost or misplaced, and have a normal position of cover that is closed for a fixed and guarded condition. So typically, if you're looking at a maintenance inspection window, for 99.9% of its lifespan, it's locked, it's closed. It's only open for those inspections that need doing on a periodic basis. And also should be lockable as an available option. Some windows are in public areas. If they're in a public area, you may have to put a padlock on or an additional lock. So this is something you might need to consider going forward. The other things you've got to look at is the lens materials. They should be able to withstand mechanical impact and load test requirements with the cover open. So the cover should be open when you're doing an impact and load test. Have a fixed and stable transmission rate for the life of the unit. Some of the fluoride crystals will degrade over time. So the polymer based crystals we find are much more stable. They don't lose transmission over time and are a far better option for the long-term viability of the system. They need to transmit infrared energy and also be using the visual and ultraviolet wavelengths. UV cameras are being used more and more, becoming very popular in more of the medium to high voltage systems. Above 2 kV, you can start to see a phenomenon called corona. So ultraviolet cameras, again, you may not be using them now but you might be using them in 3, 4, 5 years time on your medium and high voltage switchgear. So you want to make sure your system can enable that. They need to transmit infrared radiation in the mid-wave and long-wave ranges, so basically between 3 and 12 microns. Again, 20 years ago we were using mid-wave cameras, 3 to 5 microns. Then all of a sudden the long-wave cameras became much more popular, and now we're using long-wave cameras more and more. But all of a sudden you never know where the trends might go, and they might go back to using mid-wave cameras. So again, have a lens system that can utilize mid-wave and long-wave infrared ranges. Be able to withstand prolonged exposure to vibration without cracking or degrading. Again, these are test requirements of the OEMs and the standards like UL and CSA, etc. The inspection window lens must also withstand prolonged exposure to direct sunlight without degrading. Not absorb moisture such as water, so as we do know that fluoride based crystals are hygroscopic and they will absorb water over time, water, acids and alkalis, the humidity, and that will degrade the lens system. So again, you don't want anything that's hygroscopic. Be of an IP2X fail-safe design. So again, having a fail-safe, most electrical systems have a fail-safe built in, and your inspection window should be nothing different. So if it's ever damaged in any way, there should be some reinforcement that give you an IP2X fail-safe design. Be able to withstand temperatures up to 250 Celsius. And again, not a lot of electrical panels work this way, but you want to make sure your lens systems, etc., can withstand some level of exposure to excessive heat. Be resistant to light acids and alkalis and water. Again, this non-hygroscopic. Be non-carcinogenic, using non-toxic materials, and you'll see there are certain regulations that require these non-carcinogenic materials to be in. There's a complete list of substances there which are banned, and you need to make sure aren't involved in any of the gaskets or the lens systems used in your inspection windows. So all inspection windows must have all relevant certifications for the following. UL 50V is the standard for infrared viewports. Now, many years ago we used to use UL 508, which was the standard for the electrical cabinets, but 4 or 5 years ago UL 50V was the standard that came out because infrared viewports were becoming more and more popular, and they were being used extensively. So this standard was brought out with the requirements for the mechanical systems involved in an infrared viewport, and in this case we utilize these standards for the mechanical inspection windows anyway. Environmental certifications. This is another area you need to make sure you're covered. So UL 50E is the standard for environmental testing. The IP ratings, the ingress protection ratings need to be maintained. NEMA is another ingress protection rating. These are the environmental sealing requirements of any inspection window system. UL 94 5EA flammability testing on the lens of gaskets and bodies. So UL 94 5EA is very important, especially when you're utilizing polymeric based materials. It doesn't apply so much on the fluoride based materials because they are exempt a lot of this testing, but the polymer based materials need to make sure that they pass the UL 94 5EA flammability test. Another thing is the impact and load test with covers removed per ANSI UL 508A, IEEE C3720.2 section A.3.6, UL 1558 and UL 746C, and CSA C22.2 number 14-10 for Canada. So these again are very important. These are the impact and load test requirements, but you should insist that these are done, these mechanical tests are done with the covers removed. That way the lens system itself is put through the test, and then you have a mechanically strong unit. Other things you might consider: marine, if you're in the marine certification requirements such as Lloyd's of London, American Bureau of Shipping, ABS, and DMV. These are all marine specifications. So if you're in the marine or petrochem market space, these are probably stuff that you want to make sure is in place as well. Now, performance inspections is very, very important, and again, you need to consider this stuff. All inspection windows must meet the following performance specifications: Temperature, yeah, must be able to operate in ambient environments up to 100 Celsius. So that's the actual performance specifications of the lens. Now we know that I've said in previous slides they should be able to meet, be safe up to 250 degrees. That's fine, but we're actually talking about their physical operating temperatures now that they should be able to meet. Arc containment tested, they should be tested for compliance with IEC 6227-200 for metal clad switchgear. And again, there's no such thing as an arc resistant window, but we can do arc containment testing, and that's an important thing to basically show you the strength of the unit. Another test for compliance to IEC IEEE C3720.7 Type B for arc resistant switchgear. This is another test that you want to insist that it's done to show that compliance to meet at least those minimum performance standards. Now, all inspection windows should also meet the infrared lens transmission rate. I spoke briefly about infrared transmission. It's super important, yeah. So basically, your lens material must have a fixed and stable transmission rate over their entire operating life. So you do want to use hygroscopic materials because they will change over the terms of their life. So you don't need that. You need something that stays fixed and stable. And if it's fixed and stable, you can use it today, you can use it in 20 years, the transmission rates are going to be the same. Inspection equipment capability, yeah, they must be usable with all makes and models of focusable infrared cameras, including cameras with dual visual, digital and infrared capabilities. Yeah, must have visual inspection capability and must be capable with compatible with all makes of ultraviolet cameras. And all provisions for ultrasound and partial discharge testing must be IP2X compliant. So if you're going to build ultrasound ports or partial discharge ports into your maintenance inspection windows, it should be IP2X compliant. Okay, so these are just the what we class as the performance specification requirements of inspection window systems. So warranty is a very important point, and inspection windows shall carry an unconditional lifetime warranty. Inspection window manufacturers shall repair, replace, or any inspection window or component thereof with the same or next generation model if the product has ceased to perform to the end user's expectations for any reasons. Yeah, the term of warranty should be for the lifetime of the installation. There should be no exemptions under this warranty, and products shall be eligible for replacement so long as they are used within the specifications for the intended use. So if it's built and designed for use within electrical panels and it's used that way, then all of these warranty requirements should be maintained. So the benefits of utilizing a maintenance inspection window are that we remove the high-risk behaviors associated with open panel energized inspections of electrical assets by maintaining what we class as an enclosed and guarded condition at all times. Now we see grills being used a lot now, and again, grills are guarded but they're not enclosed. So the whole idea of having an inspection window system is we maintain that internal environment in a stable condition. If you open a grill, you're opening a large vent, and some of these grills are 6 inches by 6 inches, I've seen them, and those can actually enable an arc flash event to occur because we're not maintaining that enclosed condition. So make sure you have an enclosed and guarded condition at all times. They enable us to do these fully loaded inspections in line with standards like NFPA 70E, which require a minimum of 40% load at any time. Condition monitoring of equipment, it really needs to be done under a loaded condition, otherwise it really doesn't have any value. They enable us to access inaccessible equipment because the panels remain closed. Yeah, there's no triggers of an arc flash, and you're not standing in front of energized equipment, so everything becomes accessible. The inspections are much faster, much less manpower is required. One person can do this because you haven't got 2 people removing covers, etc. Lower personal protection equipment levels because obviously the panel is in a closed condition, so the arc flash levels are not elevated, nor is there PPE requirements. The increased inspection frequencies are a great bonus because obviously ease of access, we can get in there quicker, we can do the inspections quicker, and then we're going to do a lot more because we've removed those barriers on the incumbencies to doing energised inspections, as well as the danger. And then we get an increased ROI on critical asset surveillance technology, equipment and training. So again, the investments that we make in all of the equipment that we use to do these inspections, as well as the training for our staff, is going to be used a lot more because we've given them the safe access to do it. So in summary, maintenance inspection windows should allow access for all types of condition maintenance equipment. They should have a flexible and customizable design options to meet the client's requirements. There's no such thing as a standard electrical inspection, so why should it be a standard maintenance window? So we need to be able to customize these systems to meet our exact requirements. They should hold all relevant certifications for the markets that they intend that will be used in. And they must meet or exceed the mechanical and environmental testing requirements of the OEMs and the certification bodies for the industry in which we're going to utilize them. So I'd like to thank you for attending this webinar. We do have a white paper that you can download from www.iris.com on the standards and specifications, as well as the formulas and that I showed for calculating field of view. That's all available from our website. Or if you want to just send an email to info@iris.com, we can send the stuff straight to you. And again, thank you very much for attending. Be safe, and if there's anything else we can do for you, just reach out to us at IRIS.